Edexcel IGCSE Chemistry, quick revision of Section 1, Particles and Mixtures. Elements, compounds, and mixtures. Elements are formed of only one type of atoms and they are represented by a symbol that has one or two letters. The first letter has to be uppercase, the second one is a lowercase. They can exist as individual atoms or as a molecule, something like chlorine, oxygen, and hydrogen. Each of these elements have two atoms. Compounds, when two or more different atoms are chemically combined, they form compounds. They are represented by a molecular formula that represent the exact number of atoms in each compound. For example, carbon dioxide, 1 carbon, 2 oxygen, or water, 2 hydrogen, 1 oxygen. The different atoms within a compound cannot be separated using physical processes because they are chemically combined, and the properties of the compound is different from the properties of the different elements that formed that compound. For example, iron sulfide. The iron sulfide is non-magnetic, whilst the iron is magnetic. Mixture is formed when two or more different elements or compounds are mixed together. They are not chemically combined. And the mixture can be mixture of, for example, here, as we can see, is a mixture of an element and a compound. This is another example of mixture of different elements, three different elements together. Air is an example of a mixture because air is formed of carbon dioxide, water, vapor, nitrogen, oxygen, and argon. The properties of the mixture is a mix of the properties of its components. And the mixture, because they are not chemically combined, they can be separated using physical processes. So separation of the component of the mixture. So when two or more elements or compounds are mixed together, they form the mixture. There is no chemical bond here, so the different component of the mixture can be separated by the physical processes. The process of the separation will depend on the nature of the mixture. So we could separate solids from liquid, liquid from a solution, mixture of liquids, or mixture of solid. First physical process for separation is the filtration, and it's used to separate insoluble solid from a liquid. For the filtration process, you will need a conical flask, you will need funnel, filter paper, and then the mixture of the insoluble solid and the liquid is poured down the filter paper, where the insoluble solid will collect on the filter paper. This is called the residue, and then the solvent or the liquid will then pass through the funnel into the conical flask, and this is called the filtrate, which is the filtered liquid. Evaporation is the process we use to separate the soluble solid from a liquid. In the evaporation process, you heat the solution in an using evaporating dish and heat it with a Bunsen burner, where the solvent will start to evaporate. You keep it on the Bunsen burner until all the solvent has evaporated completely and only the solid remains. Crystallization is another process that can be used to separate soluble solid from a liquid. In crystallization, there are several processes or several steps. The first step is heating, putting the solution in an evaporating dish and heating, where only some of the water evaporates. So the solution gets concentrated. You keep heating until you start to see crystals forming on the walls of the evaporating dish. This is called the point of crystallization. Once the once the crystals starts to form, you then take the evaporating dish out of the heating and then leave it to cool and to form more crystals. The final step is that you filter the crystals that have been formed using the funnel and filter paper and the flask. Separating of the component of a rock salt, which is a mixture of solids. The rock salt is a mixture of sand and salt. The sand is insoluble in water, while the salt, which is sodium chloride, is soluble in water. The first step is to grind these two components together, and then you dissolve them in water and mix well. Only the sodium chloride will dissolve, while the sand will not dissolve. The next step is to filter the sand from the solution of the sodium chloride, where the residue will contain the insoluble sand, while the filtrate here will contain a salt solution. Then you can separate the salt from the liquid or from the water by using crystallization. Separation of a liquid from a solution, mainly from a solid, we use simple distillation. In simple distillation, you have your solution, put it in a round bottom flask, and you heat it using Bunsen burner, and then the steam will start to form or the solvent will start to evaporate. You connect your round bottom flask with a Liebig condenser where it has cooling water. Water goes in from the bottom and goes out from the top. And then the liquid or the vapors, as they pass through the Liebig condenser, they will start to condense, and then the condensing liquid will collect at the bottom of the Liebig condenser. And then we have a receiving flask where we have the collected or the distilled liquid. If we have a mixture of liquids and we want to separate out a liquid from a mixture of liquids, we use fractional distillation. In fractional distillation, again, we have the mixture of liquid in a round bottom flask. We heat it using Bunsen burner, but at the top of the round bottom flask, we connect it with what's called the fractionating column. The different liquids would start to evaporate and vapors will form. The fractionating column has higher temperature at the bottom and lower temperature at the top. So only the liquid which has the lower boiling point will reach the top of the fractionating column as vapors, and then it will pass through the Liebig condenser, which again has the cooling water, the water in from the bottom, water out from the top. The liquid with the lower boiling point will start to condense as it goes through the condenser, and it will be condensed and it will be collected on the receiving flask at the other end. Paper chromatography is an analytical technique that is used to separate compounds depending on their relative speed in a solvent as it spread through a paper. The more soluble the substance, the further it will moves up the paper. In paper chromatography, you use filter paper and then you draw a line at the bottom of the filter paper. This is called the baseline. When you draw the baseline, you have to use a pencil. Don't use ink, otherwise the ink will dissolve in the solvent we use, which is going to disturb your chromatogram. And then the different component, you bought your filter paper. After you bought your different spots, you put it in the solvent. Make sure that the level of the solvent is below the start line that you drew or the baseline. Otherwise, if the line is below the level of the water, or if immersed in the solvent or in water, then the different spots will dissolve in the solvent, and that will disturb your chromatogram. The different components will start to separate and to move through the paper at different speeds. Chromatography definitions. The chromatography is a separation technique. We use mobile phase and we use a stationary phase. The mobile phase is the solvent that you use, and the mobile phase will carry the soluble components of the mixture. The greater the solubility of the component in the solvent, the faster it moves through the paper. And the stationary phase, which is the filter paper in this case, it will slow the movement of the component attracted to it. The stronger the interaction between the different component and the stationary phase, the slower the component move. The separation here will be the result of the balance between the component's interaction with the stationary phase and the mobile phase. We can use paper chromatography to calculate what's called the RF value. And RF is the distance moved by the spot over the distance moved by the solvent. The distance moved by the spot is calculated from the start line to the center of the spot, and then the distance moved by the solvent is calculated from the start line to the solvent front. And the solvent front is the maximum height the solvent reached on the filter paper. RF value can be used to identify each component. And remember, the RF value will be anything between 0 and 1. 0 means that the spot didn't move at all, and that means that the particular component does not dissolve in the solvent you used. You can change the RF value if you change the stationary phase or if you change the mobile phase. State of matters. There are three different states of matters: solid, liquid, and gases. Solids have the particles are arranged regularly, and the movement of the particle, they only vibrate about fixed position. The particles are very close to each other, and they have definite volume and fixed shape. For liquids, they are randomly arranged, and remember, when you draw a liquid, they have to be attached, but they are randomly arranged. They move around each other and they still close to each other. They have fixed volume, but they take the shape of the container. Gases, on the other hand, are randomly arranged, as we can see. They move quickly in all directions. They are so far apart from each other, and they don't have definite volume or definite shape. The change between the different states of matter, this is called a physical change between states, and physical change doesn't change the particles, they only change the arrangement or the energy of the particle. First of all, the change from solid to a liquid, this is called melting. When the solid is heated, the particles will gain energy and they will start to vibrate faster. So the forces of attraction between the particle will weaken, and at melting point, the particle have enough energy to break from their position. They will start to melt and solid becomes liquid. The change from liquid into a gas is called boiling. When the liquid is heated, particle gain more energy. They start to move faster. The forces of attraction between the particles will weaken even more, and they will be able to break the bond that hold the liquid particles together. So at boiling point, the particles have enough energy to break their intermolecular forces, and then they will boil and the liquid becomes gas. Change from gas to a liquid called condensing. The gas cools down and the particles lose energy. They move slower. The forces between the particles will be regained. At boiling points, the particles have enough intermolecular forces between them, so they start to condense and the gas becomes a liquid. Liquid change into a solid. This is called freezing, where the liquid cools and the particles lose their energy. They will move slower, and the particles cannot overcome the forces of attraction between them. More stronger forces of attraction between the particle. At melting point, the particles have enough intermolecular forces between them. They only start to vibrate around the fixed position. At freezing, the liquid becomes a solid. The solid can change directly into a gas, and this is called sublimation, and the gas can change directly into the solid, and this is called deposition. Diffusion. Diffusion is the gradual movement of particles from places of higher concentration to a place of lower concentration. The movement of, you can see that through the movement of particles through a liquid or a gas. An example of a diffusion of a solid through a liquid is the diffusion of the colored potassium manganate and water. When you add potassium manganate to water, you can see at the beginning the color is only at the bottom of the beaker, and then as the potassium manganate starts, which is a solid, which starts to diffuse through water, the color starts to spread in the liquid. And then finally, after some time, when all the particle diffuses through the water, it starts to the whole solution starts to be colored. You can also see that if you add more water to that solution, the color will fade because the particles of potassium manganate will be diffused or will be separated even more away from each other, and then the color will fade. This is called dilution. We can see the movement of gases through air if we do the experiment of the diffusion of ammonia and hydrogen chloride. So if you have a tube which is closed at both ends, and then you put a cotton wool soaked in aqueous ammonia on one side, and the cotton wool soaked in hydrochloric acid on the other side, the ammonia will start to diffuse through air from the cotton wool from one side, and the hydrogen chloride from the other side will start to diffuse. It's a gas as well, to diffuse through air. These two will start to diffuse, and then when they meet, they will react together to form a ring of ammonium chloride, which is a solid. If you can notice that this ring is not formed in the center or in the middle between the two cotton walls, but it will be closer to the hydrogen chloride because ammonia is smaller in size and it's quicker when it diffuses or it diffuses through air quicker than hydrogen chloride, so it travels longer distance than hydrogen chloride when they meet. So this is why the ring is closer to the hydrogen chloride. We can also see the movement of gases through air when we see the bromine gas, diffusion of bromine gas through air. So if you have two tubes, two inverted tubes, one has bromine gas and the other one has air, and there is a glass plate between them. Now they are separated. And then when you remove the glass plate, you can see that the bromine gas will slowly diffuses through air and the color starts to diffuse. And then when the bromine completely diffuses through the air, the color becomes more faded because the particles of bromine completely diffused through the particles of air. Solutions. Solution is formed when a solid, which is a solute, starts to diffuses through a liquid, which is called the solvent, and a solution is formed when the particles completely diffuses through the solvent. So a solution is a mixture of a solute and a solvent that do not separate out. A solute is the substance that being dissolved. It could be a solid and it also could be a gas. And a solvent is the liquid the solute dissolves in. A saturated solution is a solution where the maximum amount of the solute has been dissolved, so no more solute can dissolve anymore. Solubility is how much solute will dissolve in a solvent. It's measured in a gram solute per 100-gram solvent, and we can draw the graphs of solubility versus temperature, which is called the solubility curve. This is the solubility curve of ammonium chloride, where the x-axis we have the temperature in degrees Celsius, and the y-axis will be the solubility gram per 100-gram water. The different solutes will have different shapes of their solubility curve. In your exam, if they give you the data and ask you to draw the solubility curve, you just draw the line of best fit, and it could be a straight line or curved line. Remember that solubility of the solids increases with the increase of the temperature, while the solubility of gases decreases with the increase in the temperature. You can calculate solubility of any solute if you do an experiment where you prepare a saturated solution and then you take some of that solution and you evaporate it. Then